Okay, let's unpack this. Have you ever wanted to look behind the curtain? Not at the perfect diagrams or the lofty white papers, but at the real kind of messy, sometimes frustrating, but also sometimes triumphant process of people actually building and using this bleeding edge tech.
Yeah, it's totally the difference between the blueprint and the actual construction site, right?
Hmm.
The plan looks neat, perfect on paper, but the reality involves, unexpected rain, missing parts, and people having to invent clever workarounds right there on the spot.
Exactly. And for this deep dive, that construction site, it was the Discord servers back in early 2025. They were just filled with developers, users, early adopters, all wrestling with Cardano's Hydra Head protocol.
Yeah.
So we took a whole stack of those conversations, the questions, the bug reports, the fixes people were suggesting, and sort of boiled them down.
Think of it like listening in on the community chatter, how they were collectively figuring out the practical side of things, getting Hydra heads actually up and running, and then trying to build stuff on top of them.
Right. So our mission here in this deep dive is to give you that, let's say, 20,000-foot view of that real-world experience. We're going to surface the most common challenges people were hitting with Hydra during that specific time, pulled right from those chats. And importantly, we'll highlight the practical steps, the simple workarounds, the initial solutions that came out of those discussions. Basically, what were the hurdles and what did the community actually do about them?
Yeah, it's a really cool snapshot of the challenges, definitely, but also the resilience you see in open source development. It's people helping people, really.
Okay, so let's dive into navigating this terrain. The very first major theme, and this dominated a lot of the early talk, was simply getting started, the initial setup and configuration steps.
Oh, yeah, right out of the gate. A lot of users stumbled on the fundamentals just trying to run the demo scripts provided or installing the software they needed, like the Cardano node alongside the hydra-node, or even just getting that initial configuration file absolutely perfect. It wasn't always straightforward.
We saw some really specific examples of this in the sources. Do you remember that user who was like tearing their hair out because a simple demo script kept giving them wrong transaction IDs?
Oh, yeah. And the community figured out it was because a command in the script, totally separate from Hydra itself, was using head -1.
Which is a Linux thing, right? It chops off the last byte.
Exactly. It literally just removes the last byte of whatever it's processing. And in this case, that last byte happened to be part of the transaction ID, making the whole thing invalid.
Wow. So a single character difference.
Yeah, a tiny detail in a script, nothing to do with the core Hydra protocol, causing probably hours of debugging pain. And the fix, once they found it, was dead simple. Just remove that myC1 part. It's such a classic example of the surrounding environment getting in the way of the actual tech you're trying to use.
That's wild. One character. It really shows how those little details matter when you're putting different tools together. And beyond scripts, just installing the thing presented hurdles, didn't it? Especially for people on different kinds of computers.
Absolutely. We saw that again and again, particularly for users on the newer Macs with ARM chips like the M1s or M2s. The compiled Hydra binaries, or maybe the demo dependencies, they were often built for the older by 8664 architecture.
Right.
So this meant that required libraries, things like specific versions of libcom, well, they just wouldn't load.
Yeah.
Because the system was looking for them in like the specific NIC store paths where the ARM-compatible versions weren't installed by default.
And the fix the community came up with wasn't exactly super easy for maybe a non-developer, but they shared it, right? It involved creating a symbolic link.
Yeah, a symlink. Basically, it's like a shortcut.
Okay.
Pointing from where the system could find the right ARM library, maybe installed using Homebrew or something, to the specific path where Hydra was expecting to find the by 8664 version.
It's a clever little workaround.
Yeah, a creative kind of low-level fix to bridge that gap between the different hardware and what the software was expecting.
Another really basic but common problem was people just struggling to find essential files. I remember seeing lots about the node socket path, the thing needed for tools like Cardano to actually talk to the running Cardano node, getting connection refused errors.
And that often just boils down to, double checking your file paths, maybe checking permissions, or making sure things like Docker volumes are set up right so the Hydra container can actually see the node socket. It's fundamental stuff, really, system admin basics, but it's a common barrier for people just jumping in. And again, the community was there giving troubleshooting steps, telling people where to check logs, confirm paths.
Yeah, the community support seems key. And then configuration consistency caused headaches too, right? Especially when newer Hydra versions started using etc. for managing the peer network. Someone hit a cluster ID mismatch error.
Right, etc. It's basically this distributed key value store, and here it's used to manage how the hydra nodes find and talk to each other. So if your peer configuration isn't perfectly identical across all the nodes participating in the head, things like your peer, listen, advertised parameters, etc., thinks they belong to different groups, basically. And boom, you get that mismatch error.
So the fix is just meticulous checking.
Pretty much. Meticulous cross-checking of those settings. Often people were helped by updated documentation or someone sharing a specific example in the chat for, say, a static topology setup. Just going to make sure everyone's singing from the same song sheet configuration-wise.
Okay, so looking at this first wave of issues,
Yeah.
it seems like many weren't really deep protocol bugs, but more like the expected friction, right? Setting up complex distributed software in all sorts of different user environments.
Exactly. And the key takeaway here, I think, is that while, yeah, it was frustrating for people, most of those initial setup problems back in early 2025, they seemed to have discoverable fixes, often relatively simple ones, that were being actively shared peer-to-peer right there in the community chats.
It really highlights the value of that community layer, doesn't it? Making this cutting-edge stuff actually usable for more people.
Couldn't agree more.
Okay, so moving beyond just getting it installed and configured,
Yeah.
let's look at the challenges people face once they were actually running the Hydra heads, the sort of operational stumbles.
Right. Okay, so now the head is technically up. It's functional. But actually interacting with it or managing its life cycle, that surfaced a whole different set of issues.
One thing people seem to notice pretty commonly was delays when open in head. Like, it took a noticeable amount of time to go from the committed state, where funds are locked on layer 1, ready to go to the actual open state, where you can start doing the off-chain transactions.
Yeah, and that delay, it's directly tied to waiting for that initial transaction, the init transaction, to get confirmed on layer 1. And Cardano's L1 block times, well, they mean this isn't instantaneous.
Makes sense.
So the straightforward workaround suggested in the sources was pretty simple, really. Just open the head in advance. Like, before your game night or your collaborative session is actually scheduled to start, don't wait until the last minute.
Simple, practical advice, born from people actually using it.
Okay, what about newer features? I remember incremental commits were causing some specific validation problems.
Yes, incremental commits, that's the feature that lets participants add more funds to a head that's already open. Super powerful feature, really useful. But yeah, users were reporting transactions trying to do these commits that were getting stuck. They'd see validation failures, specifically these DO1 errors in their logs, and the commits just wouldn't finalize.
Okay. And was there a simple fix for that DDO1 error emerging? There was. It came down to adjusting the deposit deadline parameter for their hydra-node. It seemed like the default setting, maybe okay for local testing, was just too short for the realities of public network block times and, transaction propagation delays. So increasing that deadline parameter resolved the D01 error for several users.
Ah, another parameter tweak, fixing things. Good to know. But it sounds like things got significantly more complex when people tried committing specific types of UTXOs. Not just ADA, but things with scripts and tokens.
Oh yeah, that's where it got hairy. We saw reports of errors like H4 popping up during the commit process for these more complex UTXOs. And sometimes these issues even stop a canna from being finalized correctly later on when trying to fan out the final state back to layer 1. Or an user was really digging into why committing a script UTXO that also had tokens was failing, and then blocking the fan out later.
So what was the debugging process there?
Less straightforward. Much less straightforward. Debugging those situations means looking way deeper. You have to check fundamental things like, did the script UTXO even have enough ADA attached to cover potential execution costs if it were spent back on L1? And you had to meticulously check how the tokens were being handled during that commit. The sources mentioned some suspicious activity, like tokens maybe getting burned or created unexpectedly during the deposit phase in some failing scenarios. It hinted at really complex interaction bugs, maybe between the script logic itself and how the head protocol handles assets. These were definitely more involved debugging sessions needing deep log dives and a good understanding of the protocol.
Okay, so not a simple parameter fix for those ones. And I think there were also some reports of intermittent peer connectivity issues, especially in Docker setups.
Yeah, that came up too. With etc. handling the networking, sometimes these issues pointed back to those configuration mismatches we talked about, or maybe just the complexities of networking within container environments like Docker. It just highlights that getting robust peer discovery and connectivity in a distributed system like this is, an ongoing area of refinement. And again, the standard advice from the community was check your logs, make absolutely sure your configurations are consistent across all the nodes.
Right. So these operational stumbles, they really ranged, didn't they? From straightforward things like scheduling, just opening the head earlier, to specific parameter tweaks for newer features, and then all the way to these much more complex debugging efforts needed for richer on-chain state like scripts and tokens.
Precisely. It shows how the challenges evolved as people moved from just basic functionality to trying out more advanced use cases. Some fixes were quick wins discovered by the community. Others needed, rolling up your sleeves and diving into logs, often with help from others in the chat.
Okay, now let's pull back a bit and look at the sort of big picture themes that came out of these conversations. These aren't just user errors or simple config fixes, but they touch on challenges that seem inherent in the protocol's design, or they have pretty big implications for how you actually build applications on top of Hydra.
Yeah, these points really highlight the fundamental characteristics of Hydra, what it is and what that means for its capabilities and maybe its limitations in practice.
One point that came up quite a bit, and I think someone in the sources described it as unfortunate, was the basic requirement that all participants in a Hydra head have to sign snapshots for the head to actually make progress.
Right. A snapshot is essentially like an agreed upon state of the head. Player A now has X80A, player B has Y80A, the game board looks like this. And if even one participant in that head suddenly goes offline or just refuses to sign the next snapshot, the head effectively freezes. It can't make any more progress off-chain.
So there's a strong dependency there.
A very strong dependency among all participants for the head's liveness, yeah.
And this requirement, it has direct implications when people start thinking about scaling up to loads of users, right? Like trying to support, say, 10,000 players in one big game world. Someone asked about managing interactions between users who'd inevitably have to be split across many different heads.
Exactly. And the core challenge that was identified is that interaction between users who are in separate Hydra heads, well, that's not really a native feature. Hydra is designed as this fast channel for a specific, defined group of participants.
Okay.
So if you want complex interactions between different groups and different heads, you often have to either fall back to doing transactions on layer 1, which can be slow and costly, kind of defeating the purpose of L2 for that specific interaction, or you'd need to rely on future features, things like cross-head communication or aggregation mechanisms, which back in early 2025 were still very much research topics, or on the long-term roadmap, often stemming from things like Catalyst proposals.
Gotcha. So while Hydra is great for transactions within a small known group, coordinating activity and state across thousands of users spread among maybe hundreds or thousands of different heads.
Yeah.
That's a whole separate, complex problem. It needs solutions built on top of individual heads, or maybe future protocol upgrades.
That's it exactly. You get scaling within the head, but scaling the whole application across many heads often brings you back to L1 bottlenecks or requires building additional coordination layers yourself.
Right. Another really significant discussion point seemed to revolve around building, say, gaming economies, and the very practical question of who actually pays for the transactions.
Yeah, users were understandably excited about the idea of fee-less in-game transactions using Hydra. And, I mean, it's true to an extent. Transactions within an open head, updating that off-chain state using snapshots, they don't require explicit Cardano transaction fees for each update.
And there's always a but, isn't there?
Haha, usually. But the sources were very clear. Those crucial layer 1 transactions still exist. The initial init transaction to open the head, the commit transactions everyone uses to deposit their funds into it, and then the fanout transaction at the end to close the head and get the final balances back out to L1, those do still incur standard Cardano network fees.
Which led to practical discussions about who pays those fees, right? Like maybe the game developer runs the hydra-nodes for the players.
Exactly. And as one person in the sources kind of wryly put it, this can feel a bit like a trust us bros scenario, where the players are basically trusting the developer to manage the L2 infrastructure correctly and potentially absorb those L1 costs.
Which I guess is a trade-off developers might make for a smoother user experience. Centralizing the operational hassle and the fee payment, even though the funds themselves are still secured by the L1 script.
Precisely. And discussions also touched on exploring other ways to handle fees, like using Babel fees if and when they became widely available and integrated, allowing users to pay L1 fees in tokens other than ADA. Or maybe services that abstract this today using existing L1 features.
Interesting. And finally, there were some comparisons popping up occasionally, weren't there, between Hydra and maybe other projects aiming for scalability, like Midgard.
Yeah, brief mentions. Those conversations often framed Hydra as, the solution that exists and works now, especially with features like incremental commits offering some similar practical benefits to optimistic rollups in terms of adding funds later. It was often contrasted with projects that might still have been more in the research or white paper stage at that time. It was about evaluating what was actually deployable then and there.
So these bigger picture points, they're not quick user fixes. They're more like inherent characteristics or maybe areas of ongoing development that really shape what kinds of applications Hydra was best suited for back then and what challenges builders needed to solve at a higher level to reach broader goals.
Absolutely. Understanding these design trade-offs and their implications is just crucial for anyone evaluating Hydra or planning to build something significant with it.
You're seeing the real capabilities and maybe the limitations too, not just the theoretical peak performance claims.
Exactly that. The view from the construction site, not just the blueprint.
So stepping back and looking at this whole cross-section of conversations, from the basic setup errors and those little script fixes, through the operational stuff like transactions and parameters, all the way up to these big picture design trade-offs. What does seeing this real-world picture mean for you, the listener?
Well, I think it means you get a much clearer, more grounded perspective on what using and building on Hydra was actually like back in early 2025. You see that, yeah, many initial issues are pretty common, maybe environmental or just configuration hiccups. And crucially, you see just how vital that community is in spotting these problems and sharing practical workarounds and solutions.
Yeah, it's definitely not a perfect, seamless experience right out of the box.
Yeah.
I mean, what cutting-edge tech ever is. But the sources really show this dynamic process of discovery, debugging, and people solving problems together. You see the state of play, the known issues, the simple fixes that did exist, and also the bigger challenges that were influencing how Hydra was being used, and maybe what was still being built or researched for the future.
It really is the reality of innovation, isn't it? Sort of building the plane while you're flying it, but doing it together as a community.
We've covered quite a range, haven't we? From those basic setup issues needing script edits or config tweaks, through the operational stumbles that needed parameter adjustments or sometimes deeper debugging, all the way to those complex protocol characteristics and design trade-offs that dictate how Hydra could be effectively used and scaled.
And the value of the community just shines through in all of that, navigating these diverse issues, from the simple stuff to the really complex debugging. It's undeniable looking at those chats.
Okay, so here's where it gets really interesting, I think, and maybe something for you to think about as we wrap up. We highlighted that core Hydra design choice, the one requiring all participants in a head to be present and actively signing snapshots for anything to happen, for progress to be made. Now, this isn't just a technical detail. It feels like a really fundamental requirement for the head's liveness.
Yeah.
So how does that requirement shape the kinds of decentralized applications and interactions that Hydra is ultimately best positioned to enable? And maybe think about this. When the actual functioning of an L2 channel relies so heavily on the continuous liveness and coordination of a specific, often relatively small group of active participants,
Yeah.
what does decentralized truly mean in practice within that specific head?
That's a deep question.
Definitely something to mull over as Hydra continues to evolve, I think.